Hello everyone, myself Kai Chelvi, Assistant Professor, the Department of Mechatronics Engineering, SNS College of Technology. Today we are going to discuss about the topic MOD-10 counters, which is also called as a decade counter, otherwise BCD counter. Okay, so by the end of this session, you will clearly understand the concept of modulus counter and the working of a MOD-10 counter, and then it's a real-time applications. Okay, so this is the empathy of mod counter, and then first we let us begin with the real world need for mod 10 counters. So think about the digital clocks, scoreboards like visitors counters and token displays. So these systems repeatedly count from 0 to 9 and reset back to 0. This exact behavior is implemented using a mod 10 counter, also known as a decade counter. So modern counters are not just theoretical concepts, they are widely used in daily life electronic system. Okay, so this is just a recap of modulus counter. So modulus counter is a digital sequential circuit that cycle through a fixed number of states and then reset to its initial state. So the mod number represents the total number of unique states in a counting sequence. So for a counter using n flip-flop, then maximum number of state is 2 power n. So however, using external reset logic, we can design a counter for any specific modulus value such as mod 3, mod 5 or mod 10 likewise. For example, mod 3 we had seen in previous session, that is count 0 to 2, mod 5 means counts 0 to 4, mod 10 means count 0 to 9, otherwise we use mod 16 is 0 to 15. Okay, so today our focus is on that mod 10 counters. Okay, so this is mod 10 counter or decade counter or BCD counter. So a mod 10 counters is a digital circuit that counts from 0 to 9 and reset back to 0. Here the state diagram of mod 10 counter is given here, that is A to J. Okay, so here it is more than 8, that means it has 4-bit counter, that is 40 value to the 1001 and reset to the that 000. Okay, 0 to 9 binary values and then not a 10 value, it back to the 0 value. Since mod 10 requires 10 states, we need at least 4 flip-flops here. Why? Because 2 power 4 is equal to 16. So there are 16 possible states, but we only have 10 valid states. The remaining 6 are eliminated using the reset logic. Okay, so here the present state and next state. So A is a present state, B is a next state of A, B is a present state, C is a next state of B. Likewise this decade counter works. And then this is the present state next state table, state assignment, so that A is equal to 0000 and then up to J. Okay, so the counter starts from 40, which represents the decimal 0, and then with every clock pulse the count increases by 1. After reaching 1001, which is a decimal 9, the next pulse forces to the circuit to reset back to 0. uh, the unused states from 1010 to 41 are automatically cleared using AND gate or NAND gate based on the reset logic. Otherwise we take it as a don't care condition. Okay, so this ensures that the counters always cycle strictly between 0 to 9 only. Okay, so mod 10 counters are designed using JK flip-flop, T flip-flop, otherwise we are using the D flip-flop also. Actually, among these, IC7490 is a decade counter IC which is used in practical circuits. These counters are essential building blocks of digital clocks, frequency dividers, timer circuits, and then embedded system counters. Okay, so uh, this excitation map is given here, and then these are all the k map for that given values, that is jk. We are using here jk flip flop for j1 k1, j2 k2, j3 k3, and then j4 k4. So here we are using 4 flip flops, right? So there are, based on that we have the switching expressions. So and then this is the circuit diagram or a schematic diagram by using the flip-flops for decade counter. Here 4 flip-flops are used. Based on the switching expression, it is connected to the input output. The clock pulse is common to all the flip-flops, and then the 5-volt supply is given here. Okay, so this is a schematic diagram for this decade counter, and this is the mind map of MOD-10 counters, like as a summarization. Okay, so here we seen about the definition of MOD-10 counters, and here the MOD-10 counters having the types asynchronous based MOD-10 counter and synchronous based MOD-10 counter. Here what are the flip-flops used, and then how the counting sequences are getting, and then what are the advantages in this MOD-10 counter, and what are all the applications are here. Okay, so this is about the MOD-10 counters. Okay, so these are all the reference we referred for this presentation. Okay, I hope you all understand. Thank you.